This is the 7.5 video, the first one. So on Friday we worked on solving polynomial equations in factored form, and I walked you through kind of a little exploration that reviewed some of the concepts that you're already supposed to be aware of and kind of making some connections for you. So we started out and we talked about the fact that what we're trying to actually do, so at the end of our lesson on Monday, the question is, how can you solve a polynomial equation? So when we started this lesson, we talked about how when you solve a linear equation or an equation that just has like an x in it, that you move all of your variables to one side using inverse operations and all your numbers to the other, and then that's how you would solve the equation. You would get a single value for x, like x equals 5 or something like that. But we talked about with polynomial equations that we have more than just an x. We usually have what we've been looking at right now in our quadratic unit is x squared, and then we have an x, and then we have a constant. So we can't just use inverse operations. So the first thing that we did is we looked at how we could match a factored form, which this was something new. It's considered to be in factored form when the product of the factors is equal to 0. So we kind of talked about, look at these factored forms. It looks like I have two sets of parentheses, and they both have an x in them, and then it's set equal to 0. And we talked about that product means that you're multiplying at least two things together. Okay, so we started here, and we talked about, well, what do you know about factored form? Well, you didn't really know that that was the name for it. However, we do know how to multiply these back together. And then we kind of talked about how, hey, well, when we were using FOIL to multiply these, we turned things, or we were left with an answer that looked like what was over here in our standard form bubble. And so we talked about standard form, and we talked about how you start with your highest exponent and you go all the way down to your constant or your lowest exponent. So let's go ahead and do an example so that we can kind of refresh your memory if you're rewatching this as a tutorial video. So I'm going to start with the factored form, and I am going to start with the first one, letter A, x minus 1 times x minus 3 equals 0. Now if I want to go from the factored form back to standard form, what I need to do is I need to use FOIL. I need to go ahead and multiply these back together. So remember, in FOIL, you're going to multiply your first times your first. So x times x is x squared. I'm going to go ahead and multiply my last times my last. So that gives me positive 3. Then my inners make negative x, and my outers make negative 3x. Then from there I combine like terms. So I bring down my x squared, negative x and negative 3x make negative 4x, and then I bring down my plus 3, and this is still set equal to 0. So at that point we noticed that we could look at our factored form, which means that it was written as the multiplication problem, and we could multiply it back together and get to our standard form. So we matched letter A with capital letter C. Now going from standard form to our non-standard form was a little bit trickier because there wasn't really a pattern in what they had done in this last bubble. We just kind of had to look at the equations that were left there and see, did they use inverse operations to move some things around from standard form to make it non-standard. And we noticed pretty quickly that number 5, all they had done here is they had subtracted the 3 from both sides, and so that's what left us with the x squared minus 4x equals negative 3. So we were able to match those three problems together. So at that point during the lesson, I asked you guys to go ahead and use FOIL, so we were reviewing concepts from earlier in the week, and I asked you to go ahead and multiply lowercase b, c, d, and e back together and see if you can match it with its standard form. So let's go ahead and look at what you did there and if you were able to do that. So here are your completed notes. Notice that I've color-coded mine so you can see that A, C, and 5 went together because they were all circled in pink. And then B, D, and 1 go together because they're in dark blue. And then C, A, and 3 in turquoise, D, B, and 4 in orange, and then E, and 2 are in green. So for the most part, you guys did a great job of matching your factored form to your standard form. So the way that we did that, as I reviewed on the last slide, is that we multiplied, meaning we used FOIL to get from factored form to standard form. And then we had to do some problem solving in order to get from standard form to non-standard form by kind of looking at our equation and seeing if any of these we could put them back into standard form or figure out what they had done. Now, when we actually use this in our quadratic unit, I told you guys that we will be starting more than likely with an equation that is in non-standard form. It will be your job to then take that equation and rewrite it in standard form, meaning you're going to have to move x squared, your x, and your constant all to the left and set your equation equal to 0. Then from that point, you're going to learn how to factor. And then you're going to solve. Okay, so this is going to actually go from your third bubble back to your first one whenever we're using this. But our focus for today was reviewing FOIL, getting you guys to realize that this factored form and this standard form, that these are actually equivalent forms of a polynomial, and then we're going to talk about how to solve. So the next part of this lesson, we filled in this chart. So what they asked you to do here is they gave you a bunch of factored equations. So I know they're factored because there's 2 parentheses set equal to 0. So I see things being multiplied together, the product, and it's set equal to 0. And they gave us some values for x. And they asked us to evaluate the equations for each of these x values, and then if it works, meaning if when you plug it in you get 0, you put a T, and if it didn't work, you put an F. Okay, so let's just kind of review that real quick. I'm going to use this bottom equation. So the original equation was x minus 6 times x minus 1 equals 0. So they first wanted you to plug in a 1 for x. So if you did 1 minus 6 times 1 minus 1, do you get 0? Well, we know that right here, 1 minus 1 is 0. And anything times 0 is going to equal 0. So 1 minus 6 is negative 5 times 0 equals 0. So this one works. So I would put a T in my chart for 1. Then I'm going to plug in a 2. So if I did 2 minus 6 times 2 minus 1, does that equal 0? Well, 2 minus 6 is negative 4. 2 minus 1 is 1. So this does not equal 0. So I'm going to put F for false. Then I continued that process over and over and over again. So then I did a 3. So 3 minus 6 times 3 minus 1. Well, I know that the only way that I'm going to get 0 for my answer is if one of these sets of parentheses equals 0, because 0 times anything is going to equal 0. That's the 0 product property. And we started talking about that property. So let's go ahead and look in our filled-in chart so that I can talk to you about that property again. So this is what the chart looked like filled in. And most of you right away started noticing the pattern here, and some of you said, hey, well, whatever the number is that's inside the parentheses, that's going to be the ones that are true. For example, here I have x minus 1 times x minus 2 equals 0. Well, I know that in order to make that first parentheses equal 0, I have to plug in a 1 for x, because 1 minus 1 is 0. So 0 times whatever this parentheses was going to equal 0. I could also do that with the second parentheses. So 2 minus 2 is also 0. So I know that 0 times whatever this parentheses equals would give me 0. So those were my two trues, and everything else was false. And this pattern kept continuing. Notice here it was x minus 2 and x minus 3. And then my solutions were 2 and 3. Here it was x minus 3 and x minus 4, and my solutions were 3 and 4. So a lot of you got to the point where you were like, well, whatever these numbers are, that's going to be my trues and everything else is false. But you didn't really understand why. So that's when we wrote this statement that I have here in green. So what you should be realizing is if the polynomial equals 0, meaning that if you have something times something and it equals 0, then one of the factors, and that's that thing in parentheses, has to be equal to 0. Because we know that a number times 0, it doesn't matter what this number is, we know that the solution is going to be 0. And that led us to our zero product property. So I'm jumping forward just a little bit because we did a little bit more exploration and talking about that just to kind of get it into your brains. But let's talk about the communicate your answer. So the first question that they asked us here is they said, well, then how can you solve a polynomial equation? And this is the part that we're going to work on some more just to make sure that you understand what you're actually doing. So the solution to a polynomial equation is the values that make the equation equal 0. So what we can do is set each polynomial factor equal to 0 and just solve for that variable. So some of you made a good connection and you said, hey, that means all of these that we've worked on have had 2 solutions, whereas in a linear equation, for the most part, we usually had 1 solution, which is great. That is true. I mean, we did have some that were special where we had no solution or infinite solutions, but more than likely a linear equation or an equation in one variable is only going to have 1 solution, whereas a quadratic, which is what we're working on right now, has 2. Now, obviously, there's going to be some, that where there's no solution or something like that, but we'll talk about that later. So then the next part is bringing you around to that property that I keep talking about. So it says one of the properties in Exploration 3 is called the zero product property. It is one of the most important properties in all of algebra. Which property is it? Why do you think it's called the zero product property? And explain how it's used in algebra and why it's so important. So this is kind of the close to this lesson. What I wanted you to get out of this is that the zero product property tells you what happens when you have a product equal to 0. It tells you that one of the factors must equal 0. And what that allows us to do is it allows us to solve polynomials by setting each polynomial factor equal to 0 and solving. So we're using the zero product property in order to solve polynomials. We know that if we have 2 or more things being multiplied together, that one of them has to equal 0. So that's what we're going to start with our lesson this week, is actually using that zero product property to solve polynomials. If you have any questions about this exploration or you want to do some extra practice, please come in for tutorials, and I will see you guys tomorrow. Have a great day.